Okay, so we are getting into our quadrilaterals unit. Does anybody know what a quadrilateral is? Hello? Excellent. A quadrilateral is a four-sided polygon. Before we start talking about the specific quadrilaterals that we're going to be dealing with in this chapter, let's first talk about what a polygon is. So polygons are plane figures. The figures to the right are examples of polygons. Notice that all the sides are segments, no curves. Sides only intersect at endpoints, and each vertex connects to exactly two sides. Okay, so in order for things to be shaped to be considered a polygon, you can't have any curves in it. So can a circle ever be a polygon? Never. Okay, also, you could only touch at vertices, which means if you have vertical angles like this, see how it's crossing in the middle? That shape that I just drew, that cannot be a polygon. You could only intersect at the main vertices, at the main angles. And every vertex can connects to exactly two sides. So what I mean is, here's a triangle. Triangle's a good polygon. So notice how vertex B connects to AB and BC, exactly two sides. Okay, vertex A connects to AB and AC, exactly two sides. Vertex C connects to CB and CA, exactly two sides. So in order for a figure to be considered a polygon, each vertex has to connect to exactly two sides, not less, not more. So let's say I have A, B, C, D, E. Right, this shape that I just drew, A, B, C, D, E, is not a polygon. How come this whole shape is not a polygon? Because if you see vertex B, it connects to BC, BA, and also BD. So it connects to more than two sides. The triangle on top, is it a polygon? Yeah. The quadrilateral on the bottom, is that a polygon? Yeah, but that whole thing, is it a polygon? No. Okay, next thing we're going to talk about is the definition of a diagonal of a polygon. The diagonal of a polygon is a segment that connects two non-consecutive, non-adjacent vertices. So what that means is, let's look at what I have here. So let's say we have A, B, C, D, E. Right, so let's say I'm going to draw a diagonal from B. So a diagonal from B can connect to any other vertex as long as it's not adjacent or consecutive to it. That means next to it. So the consecutive vertices to B are C and A, right? Those are the ones that are close by. So I can make a diagonal from B to D. That's considered a diagonal. I can also make a diagonal from B to E. That is also considered a diagonal. So multiple diagonals can come from the same vertex. That's okay. All right. Definition, a quadrilateral is a four-sided polygon. Okay, so we are going to now talk about all the different quadrilaterals that we're going to be using in this chapter, and we're going to go over the properties that they have. Okay, the first quadrilateral we're going to be talking about is a parallelogram. I shortcut parallelogram by drawing two parallel lines, and then I write ogram. It's not LLLogram, all right? It's not lelogram. All right, it's two parallel lines and then an ogram. That's how I shortcut it. All right, let's go through these properties now. There are 5 properties that we have to memorize for our parallelogram. The first property is that opposite sides are parallel. So what does that mean? That means that PL is parallel to AR and AP is parallel to RL. Right? In a parallelogram, opposite sides are also congruent. So what does that mean? Opposite sides congruent? That means AP is congruent to LR and PL is congruent to AR. Opposite angles are congruent. Now, when we talk about opposite angles, we're talking about the big angles. So that big angle by A, so angle PAR, that big angle by A is congruent to the one opposite from it. So it's congruent to that big angle L, PLR. Those are what I mean when I say the opposite angles. It's the big angles that are across from each other. So the big angle A is congruent to the big angle L. What else? What other angles do you think are congruent? Adam?
Angle P and angle R.
You got it. The big angle P is congruent to the big angle R. All right, the diagonals bisect each other. What does it mean to bisect? What does it mean when I say the diagonals bisect each other? Any ideas? The diagonals bisect each other. Mila?
The diagonal between A and L is split in half.
Good. It's not only the diagonal AL and the diagonal PR split each other in half. So let's say there's a point here. Let's call this point E in the middle. That means the segment from P to E, so we're going to put three dashes here, is congruent to the segment E to R. Now, it doesn't mean that all four parts are congruent, just the parts that are on the same line. So now the segment A to E, I'm going to put 4 dashes. 1, 2, 3, 4. That's congruent to E to L. 1, 2, 3, 4. Are P, E, E, R, A, E, and E, L all congruent? No, just the parts that are on the same segment. Then the last property for a parallelogram is any pair of consecutive angles are supplementary. What does it mean to be consecutive? What does consecutive mean, Liv?
Like next to.
Yeah, so following or next to, so like what's the next consecutive number after 1? 2. What's the consecutive day after Saturday? Sunday, right? It's following each other. It's following each other. So any pair of consecutive angles are supplement. That means this big angle A is a supplement to which angle? Angle R, but it's also a supplement to what other angle? P, right? Those are the ones that are following each other, right? So the big A is a supplement to the big R. The big A is a supplement to the big P. What about the big R? Which angles does that supplement to? Adam?
Angle A and angle L.
You got it. What about angle L? Which angles are they supplement to? James?
Angle R and angle P.
You got it. Do you guys want me to write that out for you? Or you got it? We got it? Okay, great. All right, so those are the 5 properties of a parallelogram. You need to memorize those. You need to memorize those properties. You're going to need to memorize all of these properties. This is what I was saying yesterday when if you wait too long, if you wait before the quiz or the test or whatever assessment I give you to try to memorize everything, it's not going to work out well for you. So you want to start from now. You want to start studying and memorizing these properties from now. So now, by definition, a rectangle is a parallelogram. This is huge. A rectangle is a parallelogram, but then it has an extra special feature to make it different. So because a rectangle is always a parallelogram, that means a rectangle will have all 5 properties of a parallelogram, plus some extra special features to make it better than a parallelogram. So let's go through. Now we're going to go through the properties. If it's a property of a parallelogram, we're going to write P next to that property. If it's a new extra special feature, we'll put a star. So opposite sides are parallel. Is that a parallelogram or is that a new extra special feature? It's a parallelogram. So let's put a P. And then let's mark it up. So if opposite sides are parallel, that means RE is parallel to TC and RT is parallel to EC. Opposite sides are congruent. Is that a parallelogram or is that a new extra special feature? Opposite sides are congruent. Adam. Again, it is a parallelogram. So that means that RT is congruent to EC and RE is congruent to TC. Right. Diagonals are congruent. Is that a new extra special feature or is that a parallelogram? Connor. This is a new extra special feature. I'm not going to mark it just yet. The diagonals are congruent, and then number 4 says the diagonals bisect each other. Diagonals bisect each other. Parallelogram or a new extra special feature? Olivia? That is a parallelogram. So now I want to combine 3 and 4, properties 3 and 4. If the diagonals are congruent, so that means, doesn't that mean if the diagonals are congruent that all of RC is congruent to all of TE? Do we agree? That's what that means? All right, so if the whole diagonals are congruent and they bisect each other, meaning they cut each other in half, what do we know about all 4 little parts? Only 2 people, Bridget? All 4 parts are congruent. So I'm going to put a point, W here. Hey, and then I'm going to show that all 4 parts are congruent. This is a huge sign that we're dealing with a rectangle. Whenever you see a quadrilateral and all 4 parts of the diagonals are congruent, it is immediately a rectangle. Immediately, because that's an extra special feature, the diagonals being congruent, and because it's a parallel, they bisect each other. It is immediately a rectangle when you see all 4 parts congruent. All right, let's keep going. All angles are right angles. Is that a new extra special feature or is that a parallelogram?
Special feature.
That is a new extra special feature. So we're going to put a star and we're going to mark the right angles. Right, opposite angles are congruent. Isn't that a parallelogram? And isn't that pointless? Because not only are opposite angles are congruent, what do we know in a rectangle since they're all right angles?
All right angles are congruent.
All the angles are congruent. So this was a parallelogram property, but it's sort of a pointless one since all the angles are congruent. Any pair of consecutive angles are supplementary. Isn't that also a parallelogram? But isn't that also pointless? Because all the angles are what? Supplements, because they're all 90, right? So if you memorize the properties of a parallelogram, to make a parallelogram a rectangle, to make it better, how many extra properties do we really need to know? 2. So a rectangle is a parallelogram with 2 extra special features to make it better. Okay, so it's not so bad. If you memorize the parallelogram, to get from a parallelogram to a rectangle won't be that difficult. Okay, let's go on to the next one. Actually, I'm going to come back to the kite. Kite is the worst one. I'll warn you from now. Kite is the worst one. We'll come back to the kite. All right, let's go to the rhombus. So once again, a rhombus is a parallelogram. Because a rhombus is a parallelogram, what does that mean about the 5 properties of a parallelogram? Olivia? Good, they're all applied to the rhombus. So because a rhombus is a parallelogram, it will have the main 5 properties plus a couple of extra special features to make it better. Right? So it is a parallelogram, so it will have the main 5 properties, but then it will have extra special features to make it better than a parallelogram. All right, so we're going to go through. If it is a property of a parallelogram, we're going to put a P. If it's a new extra special feature, we will put a star. So opposite sides are parallel. Parallelogram or new extra special feature? Parallelogram. So we got the opposite sides are parallel. All sides congruent. Parallelogram or new extra special feature? Adam. New extra special feature. So we put a star. It's a new extra special feature. So we have all sides congruent. Opposite angles are congruent. Parallelogram or new extra special feature? James. It is a parallelogram. So that means the big R is congruent to the big O, and the big M is congruent to the big H. Any pair of consecutive angles are supplements. Parallelogram or new extra special feature? Looking for some new participants here. Any pair of consecutive angles are supplements. Parallelogram or new extra special feature? So, parallelogram. Diagonals bisect each other. Parallelogram or new extra special feature? Diagonals bisect each other. Parallelogram or new extra special feature? Jocelyn? Parallelogram. So what I'm going to do is I'm going to put a point E in the middle here. So now, with the diagonals bisecting each other, did it say anywhere that the diagonals were congruent? No. So are all 4 parts going to be equal, or just the parts that are on the same segment? Just the parts that are on the same segment. So we're going to have ME congruent to EH, and we'll have RE congruent to, I think that's an O, EO. Right. Diagonals are perpendicular. Parallelogram or new extra special feature? Adam? New extra special feature. What does that mean? So let's put a star here. For the diagonals to be perpendicular, that means that, do we agree that MH is a diagonal and RO is a diagonal? So that means where those 2 diagonals cross, we're getting right angles. So where do these diagonals cross? Right here in the middle. So you get 4 90-degree angles right in the middle. That's what that means when it says the diagonals are perpendicular. Diagonals bisect pairs of opposite angles. Do we all agree this is a new extra special feature? Okay, let me explain to you what that means. Do you agree if we bisect an angle, we split it into 2 equal parts? 2 equal angles, I should say? Yeah, if you bisect an angle, you split it into 2 equal angles. So what happens is, do you see there's angles 1 and 2 here by R? There's angles 3 and 4 here by O. Now the diagonals bisect the angles means angle 1 is congruent to angle 2. But weren't the big angles that were across from each other originally congruent? If the big angles that were across from each other were originally congruent, what does that mean if they're then getting bisected? If the whole angles are congruent, then the half angles are also congruent. So not only is 1 congruent to 2 and 3 congruent to 4, angle 1 is congruent to angle 2, which is congruent to angle 3 and angle 4, because originally the whole angles were congruent. So all 4 of these angles are congruent. Same thing on the other angles. So let's call them 5 and 6 here, 7 and 8 here. Now, are 5 and 6 congruent to 1, 2, 3, and 4? No. But are 5 and 6 congruent to 7 and 8? Yes. So we get loop with 2 dashes. You do not need to know the 8th property. We can cross that out. So, a rhombus is a parallelogram with how many extra special features? 3. Very good. So if you memorize the 5 properties of a rhombus, of a parallelogram, you just need to know that there's 3 extra special features to make it special, to make it a rhombus. All right. Going on to the square. I call the square the queen bee. I call the square the queen bee. Why do you think I call the square the queen bee? Any ideas? Adam?
Because it doesn't have any special features.
It doesn't have any special features? Aren't queen bees really special? Who's the ultimate queen bee? I might be dating myself. Nobody knows the ultimate queen bee? Is Beyonce no longer the ultimate queen bee? No. Okay, well, I think Beyonce is the ultimate queen bee. Why? Not because she's not special at all, because she's the most special, or has it all, right? Whoever is the queen bee has it all. The square is the queen bee. She has it all. Right? Other people like to say the rhombus and the rectangle got married and had a baby named the square because it has all the properties of a rhombus and all the properties of the rectangle. Essentially, a square is perfect. It has everything. So, we're going to go through, and if it has all the properties of a rectangle and all the properties of a rhombus, therefore, by default, it also has all the properties of what other figure? A parallelogram. So we're going to go through these properties. If it's a property of a parallelogram, we'll put a P. If it's a property of a rectangle, we'll put an R. If it's a property of a rhombus, we'll put an RH for rhombus. All right, opposite sides are parallel. Parallelogram, rectangle, or rhombus. Which one? Parallelogram. So I'm going to put a P and then I'll mark it. All right. All sides are congruent. Parallelogram, rectangle, or rhombus. Rhombus. So I'm going to put an RH. All sides are equal. All angles are right angles. A rectangle. So I'm going to put an R. Any pair of consecutive angles are supplements.
Rhombus.
Before the rhombus, it was a property of a...
Rectangle.
Before the rectangle, it was a property of a
parallelogram.
parallelogram. This is a parallelogram. What did we say parallelogram was? Blue? Okay, diagonals are congruent. Diagonals are congruent. Rectangle, excellent. So I'm not going to mark it just yet. I'm going to pair it. Because if the diagonals are congruent, then jump to number 7. The diagonals bisect each other. So if the diagonals are congruent and the diagonals bisect each other, which property where the diagonals bisect each other? Parallelogram, rectangle, or rhombus? Diagonals bisect each other. Parallelogram. So remember, if I combine these two, them being congruent, and they bisect each other, what did we say about all 4 parts? All 4 parts had to be congruent. So I'm going to mark that. Remember, I told you all 4 parts of the diagonals congruent was a telltale of a rectangle, right? The minute we saw that, we knew it would be a rectangle. Well, is a square a rectangle? Yeah, a square is a rectangle. Is a square a rhombus? Yeah, a square is a rhombus. Is a square a parallelogram? Yes, a square is all of them. It is a parallelogram. It is a rectangle. It is a rhombus, always, because it has all of their properties. All right, back to number 6. The diagonals are perpendicular. Is that a property of a rectangle, a parallelogram, a rectangle, or a rhombus? Diagonals perpendicular. A rhombus, excellent. So we'll put RH for rhombus. And then what did that mean? 4 angles in the middle are right angles. The diagonals bisect each other. I'm sorry, not bisect each other. The diagonals bisect the angles. The diagonals bisect the angles. Is that a parallelogram, a rectangle, or a rhombus? The diagonals bisecting the angles. A rhombus. But now it's even more special because if I'm bisecting the angles, aren't all the angles 90 degrees? So if we're bisecting them, what is that turning into? 2? Yeah, but what number? 45, you got it. So they split all these angles into 2 45-degree angles. All right, we can cross out number 9. We do not need to know that. So there is our perfect square. All right, so we just went through the parallelogram, the rectangle, the rhombus, and the square. All of those were all under one main category of which one of them? They all fell under which one of them? They were all parallelograms. And then a rectangle was a parallelogram with 2 extra special features. The rhombus was a parallelogram with 3 extra special features. And the square just had it all. It was just the rectangle and rhombus all put together. We're going to go back now. We're going to go back to the kite. The kite is not a parallelogram. Since it is not a parallelogram, it will not have the properties of a parallelogram. It will have its own properties. And they're pain, these properties. Not gonna lie. I like the kite the least. I don't really like it at all. So, a kite is a quadrilateral in which 2 disjoint pairs of consecutive sides are congruent. Right, what are the properties? First property, 2 disjoint pairs of consecutive sides are congruent. What does that mean? That means in a kite, the top 2 sides are congruent and the bottom 2 sides are congruent. In a kite, the diagonals are perpendicular. Right? What does that mean if the diagonals are perpendicular? We learned about this from the rhombus. Good, in the middle. That means if the diagonals are perpendicular, that means we have right angles in the middle. Okay, number 3, one diagonal is the perpendicular bisector of the other. I'm going to put a little star for you. We're going to say long diagonal, perpendicular bisector of short diagonal. Okay, so the long diagonal, KT, is going to be the perpendicular bisector of IE. We already have the perpendicular part, right? So the bisector part means these 2 segments are congruent. Oops, 3 slashes. Okay, number 4. One of the diagonals bisects a pair of opposite angles. I'm going to write it out for you. We're going to say star long diagonal bisects angles. Okay, so that means if you look at our diagram, which one's the long diagonal? KT. So it's going to bisect the angles that it touches. So if you look up top, I can call these 1 and 2. That means angle 1's congruent to angle 2. And the angles by T, I'm going to call 3 and 4. 3 and 4 are congruent. Are 1, 2, 3, and 4 congruent? No. Just 1 and 2 are congruent, and just 3 and 4 are congruent. They're not all congruent to each other. Okay, one pair of opposite angles are congruent. So I'm going to put a star, and I'm going to write the big angles by the short diagonal are congruent. So what does that mean for us? It means the big angle OI is congruent to the big angle E. They're not being bisected, just the big angle by I is congruent to the big angle by E. All right, I need to talk a little bit more about the kite. Did we all catch up? Do we all have it written down? Okay, so I don't know if you realize, because I've just filled your brain with a lot of information, but there is something similar about the properties of a kite, very similar to another figure. Does anybody know what other figure has somewhat similar properties to a kite? Let me put it together. Diagonals are perpendicular. Diagonals bisect the angles. Milo? A rhombus. It's sort of like, you know, that song, Anything You Can Do, I Can Do Better, right? That's like a rhombus to the kite. Everything the kite can do, the rhombus can do better, because the kite just does it half. That's why we say these are half properties. So in a rhombus, the diagonals bisect both angles, right? In a kite, only the long diagonal bisects the angles. Right? In a rhombus, the diagonals bisect each other. In a kite, only the long diagonal bisects the short diagonal. Right? In a kite, the top two sides are congruent and the bottom two sides congruent. In a rhombus, all the sides are congruent. So everything a kite can do, a rhombus can do better. So there is a relationship between a kite and a rhombus, and we'll talk about that on a different day, but just keep that in mind. There is a relationship between a kite and a rhombus. All right. I know this seems so overwhelming. Okay, last two figures. Last two figures we're going to talk about, not too many properties. All right, we're talking about the trapezoid and the isosceles trapezoid. A trapezoid is not a parallelogram. Since it is not a parallelogram, will it have the 5 properties of a parallelogram? No, it will have its own properties. So definition, a trapezoid is a quadrilateral with exactly one pair of parallel sides. When I say exactly one pair of parallel sides, can we have 2 pairs of parallel sides? No, it means it's only allowed to have one pair of parallel sides. So let's say we say TR and PA are the parallel sides. Those sides that are parallel are called the bases. Base, base. And that's it. Only one property for a trapezoid. One pair of parallel sides, that's it. Now, an isosceles trapezoid is a subcategory of a trapezoid. Since an isosceles trapezoid is a trapezoid, will it have the one property of a trapezoid? Absolutely. Since it is a trapezoid, it will have that one property that a trapezoid has. What is that one property that the trapezoid has? You got it. Exactly one pair of parallel sides. So let's go through the properties of a trapezoid. In a trapezoid, in an isosceles trapezoid, the bases are parallel. So that means TR and PA are parallel. And what do we call those? The sides that are parallel? Base. So you have your upper base and you have your lower base. All right, the sides that are not parallel. So in this diagram, which sides are not parallel? In the diagram, which sides are not parallel? So? Good. The sides that are not parallel, those are going to be the sides that are congruent. So in an isosceles triangle, aren't the sides has two legs congruent? Same thing with an isosceles trapezoid. Two legs are congruent. So the sides that are not parallel are congruent. And those are called the legs, just like in an isosceles triangle. So do you guys remember in an isosceles triangle how we did legs to base angles? Do y'all remember that? It's the same idea with an isosceles trapezoid. It's legs to base angles, but it's a little bit different this time because how many bases do we have? 2. So we're going to have the big angle P congruent to the big angle A, that's the bottom base, but the top base angles are also congruent. So angle T, the big angle T is congruent to the big angle R. Okay, the diagonals are congruent. What does that mean? The diagonals are congruent means the whole segment TA is congruent to the whole segment RP. Did it say anything about the diagonals bisecting each other? No. So are all 4 parts equal? No. Just the big TA is congruent to the big RP. That's it. Any lower angle is a supplement to any upper angle. I always put an algebraic problem like this on my test, that you have to remember that any bottom angle plus any top angle equals 180, and for some reason it's always the property everybody forgets. That doesn't just mean P and T add up to 180. It means P plus T add up to 180, but also P and R add up to 180. Right? Do P and A add up to 180? No. What is the relationship between P and A? They are congruent. A and R add up to 180. What else? A and T add up to 180. So any bottom angle plus any top angle, that adds up to 180 in an isosceles trapezoid. All right. So we are done with all the properties you have to memorize. I know it's a lot. For the next 2 classes, we are not learning any more properties. This is all we have to memorize for this chapter. So I gave it to you all the first day. So next class, we'll just do algebraic problems with these quadrilaterals. The class after that, we'll focus on just doing proofs with these quadrilaterals. So we're going to get 2 more classes of practice, no more memorizing, but you want to start memorizing from now.